Lesson 5.2, adding and subtracting like and unlike fractions. Now, what I mean by like and unlike fractions, like fractions are fractions that have the same denominator, and unlike fractions, of course, would be fractions that do not have the same denominator. So, to add and, we're going to break this down into parts here. To add and subtract fractions that have the same denominator, or like fractions, you write the sum or difference over the denominator, which means basically you add the numerators, put it over the common denominator. You subtract the numerators, put it over the common denominator. This little symbol here means c cannot equal 0 because you can't have 0 in the denominator. So let's try a quick example. Simon ate 3/16 of a pizza, and Newman ate 5/16 of the pizza. What fraction of the pizza did they eat together? Well, the word together would imply addition. So I'm going to add 3/16 and 5/16. So you add the numerators, that would be 8. You keep the same denominator. Don't add the denominators. That's going to cause nothing but problems for you here. 8 over 16 is your fraction answer, but it does simplify because I can divide top and bottom by 8, and this reduces all the way down to 1/2. So they ate 1/2 of the pizza. And that would be my answer. Now let's do this for some non-story problem types. And I have find the sum or difference, 3/8 plus 2/8. 3/8 plus 2/8, notice they're like fractions, they have the common denominator, so I add the numerators, that would be 5, and I keep the same denominator, which would be 8. And in this case, 5 over 8 does not simplify. I'm going to leave my answer as 5/8. If it does reduce, like the example before about the pizza, you should simplify your answer and put them in simplest form or lowest terms. Now in the next example, I'm adding -1/6 plus +5/6. Now I see that negative is in front of the fraction bar. It's not in the numerator or the denominator, but you can imagine this as -1 plus +5. So a -1 and a +5, -1 plus 5, subtract 8 the sign of the bigger, is 4. Keep the same denominator. This one does reduce. I can divide top and bottom by 2. 2 into the top twice, 2 into the bottom 3 times. I get 2/3, and that's my answer. Now the next example is a subtraction problem. You have 2/15 minus 7/15. I'm going to subtract the numerators. Now notice here 2 minus 7, that's a non-traditional subtraction. You might be better off by first changing this to adding the opposite. And then think of this as +2 plus -7 all over 15. Well, +2 and a -7, subtract, take the sign of the bigger one, is -5 over 15. I can divide top and bottom by 5. I'm going to write this as -1/3. Now I put the negative in front of the fraction bar. I could have left it in the numerator and written this as -1 over +3. It means the same thing. My last example is another non-traditional subtraction because I'm subtracting a negative. So the first thing I'm going to do is change this to adding the opposite. And so now I have 3/16 plus +11/16. You add the numerators, that's 14, keep the same denominator. Another one that simplifies, divide top and bottom by 2, and I get 7/8. That's my answer. Now let's try to add and subtract some mixed numbers that have already have common denominators, that have like fractions. Okay? The step here that you have to do first is to change them into improper fractions. We're going to change these mixed numbers into improper fractions. Now I went over this before, but I'll review real quick. You take the denominator, you multiply it times the whole number, and then you add that to the numerator. So 4 times 2 is 8, plus 3, this would be 11/4. 4 times 5/20 plus 3 is 23/4. Now I'm going to add the numerators. That would be 34 over 4. I'm going to simplify. I can divide top and bottom here by 2. That would be 17 over 2 if I divide top and bottom by 2. But since my answer is improper, I'm going to go ahead and change it. Since the original problem was, with mixed numbers, I'll change this back into a mixed number by dividing 2 into 17. It divides in 8 times with 1 left over, and you keep the same denominator. There's my guy right there. I'll try it here where I have 1 negative, 1 positive. I'm going to first change them into improper fractions. 3 times 7, 21 plus 2. This is -23 over 3. 3 times 2, 6 plus 1, 7 over 3. Now, I have a negative 23, the negative sign, even though you can look at it and it's in front of the fraction bar, you can think of it as in the numerator, negative 23 plus a positive 7. One of each, subtract, take the sign of the bigger, that's going to be negative 16, keep the same denominator. Now since it's improper, I'll go ahead and I'll change it. 3 goes into 16 5 times with 1 left over, and keep the same denominator, negative 5 1/3. That's smeared a little bit, but that's 3 right there. Negative 5 1/3. Let me put a better 3. There we go. And that's my answer. Notice because it's a mixed number, the negative sign goes out in front. You don't leave it in the numerator or the denominator. It goes out in front of the entire number. There's your guy. This last example here on the top row, my common denominator is 12 here. So I'm going to be dealing with slightly bigger numbers, not too bad. I'm going to change this into an improper fraction. 12 times 7 is 84, plus 5 is 89. 89 all over 12. And I'm subtracting 12 times 2, 24. 24 plus 11 is 35. Keep the same denominator. Now I'm going to subtract the numerators. I have 89 minus 35 is 54. So this is 54 all over 12. Now 54 over 12 reduces. I know it's an improper fraction, but I'm going to first reduce it by dividing top and bottom by, it looks like 6. On top by 6 leaves me a 9. On the bottom by 6 leaves me a 2. 9 over 2. 2 goes to 9 4 times with 1 left over. A little bit of work there. And I get my answer is 4 1/2. And I saved the best one for last here. I know there's 2 more, but they're a little different. This guy right here, they have the common denominator 7. I'm going to first change this into adding the opposite, but I'm going to go ahead and change these 2 guys into improper fractions. 7 times 3, 21, plus 3 is 24. I'm going to write this as negative 24 over 7 plus the opposite. 7 times 6, 42, plus 3 is 45 all over 7. So I kind of did 2 steps in one. I changed them into improper fractions, and I went ahead and changed the subtraction to adding the opposite. So now I'm adding a negative 24 and a negative 45. That's a negative, looks like 69 all over 7. It does not reduce. I cannot divide anything top and bottom, but I can change it back into a mixed number. Negative 7 goes into 69 almost 10 times, 9 times with 6 left over. Keep the same denominator, and there's my guy. The other 2 examples, although they're not mixed numbers, they have variables in either the numerator or the denominator, and I want to show you what to do just in case that occurs. In this case, they're like, they have the same denominator, so I add the numerators. Now it's just like adding monomials. These are like terms up top. 3k plus 9k is 12k, so I have 12k all over 28. And then what we talked about in the last section, I can simplify this. In this case, I can divide top and bottom by 4. 4 goes in 3 times, 4 goes in 7 times, and I end up with 3k all over 7, and that's my answer, simplified. The last example that's there is a subtraction. You already have the same denominator. I keep the same denominator, and I subtract the numerators. Now it's a non-traditional subtraction, so you can think of it as adding the opposite. 4 plus negative 9 is a negative 5. I'm going to put the 5 there, and instead of putting the negative right in front of it, since it's the way I'm going to write my final answer, I'll put it there. And I have negative 5 over 7y. Now that's what you have to do as far as adding fractions, subtracting fractions, adding mixed numbers, subtracting mixed numbers, if they already have the common denominator. You know, but you have to remember, fractions are kind of like combining terms. They have to be like terms to combine them. They have to be like fractions to add and subtract them. So what we're going to have to do when we have fractions that don't have the same denominator, unlike fractions, is we're going to have to rewrite the fractions. We're going to find the least common denominator, the LCD. We're going to rewrite our fractions so that they are equivalent, but they have the least common denominator, and then we'll work them just like we've been doing in the first part of this lesson. So the trick is to rewrite unlike fractions to like fractions, but they have to be equivalent, so we have to be very careful with that, and I'm going to show you some examples. Okay, let's start out with a couple of fractions here that are unlike. They have denominators of 8 and 2. So my first step is to find the least common denominator. Remember, that's the least common multiple of the denominators. So the least common multiple of 8 and 2 would be 8, because as you can see, 8 is a multiple of 2. So 8 would be my least common denominator. Now look what I'm doing here. I'm rewriting them so that they'll have the denominators of 8. That tells me what my next step is, and my next step is to make sure I have the correct numerators that keep these fractions equivalent to those fractions. Now since this denominator is the same, the numerator is the same. But since this denominator changed from a 2 to an 8, I'm going to have to change the numerator in the same manner. To do that, to change a 2 into an 8, I would multiply by 4, so I'll have to do the same thing here. So that would give me 4 on top. Now it becomes a problem like we were just doing in the earlier part of this lesson. I'm going to add the numerators. A negative 3 plus a positive 4 is a positive 1, and I keep the same denominator. There's my answer. It does not reduce, which is kind of convenient. That's my final answer. On the next problem, my concern is the subtracting negative part right here. I'm going to change subtracting negatives to adding the opposite every single time. Now my denominators are 4 and 3, so the least common multiple of 4 and 3 is not going to be one of the existing denominators. It's going to be, in this case, 12. 12 is the smallest number that 4 and 3 are both factors of. So I'm going to rewrite this so that they have a denominator of 12. To change a 4 into a 12, you would have to multiply by 3, so I'll multiply the top by 3. To change a 3 into a 12, you would have to multiply by 4, so I'll multiply the top by 4, and that would give me an 8. A negative 3 plus a positive 8, one of each, subtract, take the side of the bigger, is going to be a positive 5, so this is going to be a positive 5 over 12. Now again, you always check to make sure it reduces, or if it reduces, to reduce it. This one doesn't. It's a proper fraction. There's my guy. On the next example, it is a subtraction problem, and this one's kind of nice because the first denominator is a multiple of the second denominator. So my LCD here is going to be 10. That's nice. When you get that part working for you, that's really convenient. And in this case, that's going to be a 10. This is already a 10, so the numerator stays the same. This, you would change to a 10 by multiplying by 2. You have to do the same thing to the top, and that becomes an 8. And what I have is a non-traditional subtraction. I'm going to change that to adding the opposite. And I have a positive 3 and a negative 8. That's a negative 5 all over 10. This one does reduce because I can divide top and bottom by 5. And I'm going to write that as negative. I'll put it out in front. 1/2. And that's my answer. Now it becomes a little more interesting with some mixed numbers involved. I have 3 and 4 ninths plus 7 and 1/12. 3 and 4 ninths I'm going to change to an improper fraction. 7 and 7 twelfths I'm going to change to an improper fraction. So 9 times 3 is 27 plus 4 is 31 over 9 plus 12 times 7 is 84. 84 plus 7 is 91 all over 12. Ooh, this one's going to be fun. My common denominator appears to be 36. That's the smallest number that 9 and 12 are factors of. So I'm going to have to rewrite each one of these to have a denominator of 36. To do this into this, you would have to multiply by 4. So 4 times the top gives me 124. To change this one into this, I would have to multiply by 3. So I multiply the top by 3. That would be 273. I add the two numerators together. It looks like 397. Yikes, 397 all over 36. Now, I don't think it simplifies. I don't think I can find anything that will divide top and bottom, because the only numbers that divide into 36, like 2 and 3 and such, don't divide into 397. But it isn't proper, so I'm going to take one extra step, and I am going to rewrite this by dividing. Now, you have to be careful. It's a little bit of a division here. 397. 36 doesn't go into 3, but goes into 39 one time. That's a 3. Bring down the 7. It goes into 37 one time. And I have 1 left over. So this is the whole number part is 11. This is the remainder, 1, and you keep the same denominator. So that becomes 11 and 136. My next problem, I'm adding a negative and a positive. By the way, students ask me, what happens if instead of a mixed number, if one's a mixed number and the other one's an integer, like just 7? Well, then I would have put the 7 over 1 and written it as a fraction before finding my LCD. Over here now, I'm adding negative 4 and 1/4, which is negative 17 over 4. 4 times 4 plus 1. And I'm adding to that 8 times 1 plus 5, 13 eighths. Well, this one's kind of nice because 8's a multiple of 4. My LCD will be 8. So I'm going to rewrite each one of these to have the common denominator of 8. To change a 4 into an 8, I would have to multiply by 2, so 2 times the top. I'm going to write that as negative 34 over 8, and then here this stays the same, so the numerator stays the same. I add a negative and a positive, which means I actually subtract the numbers and treat them like they're both positive. Subtract, take the sign of the bigger looking one, the one with the greater absolute value. So this is going to be negative 21 all over 8. Now I don't think anything will divide evenly into 21 and 8, so I can't reduce in that form, but it is improper, so I'll change it into a mixed number. It's going to be negative. 8 goes into 21 2 times with 5 left over. I can kind of do that one in my head. And I get negative 2 and 5/8. If you can do it in your head, great. Otherwise, do it on scratch paper, something to that effect. Make sure that your arithmetic is solid. All right, 5 and 4/11 minus 2 and 2/3. This looks pretty calm. I'm going to change both of these. 11 times 5, 55 plus 4 is 59 over 11. Minus 3 times 2 is 6, plus 2 is 8 over 3. Well, my LCD is going to be 33. 11 and 3 are relatively prime numbers, so their product is your LCD. So 3 times 11 gives me 33, so I got to multiply 3 times the top. That'd be 177 if I haven't made a mistake there. I'm going to have to multiply this by 11 to make it a 33, so 11 times the top would give me 88. So 177 minus 88, I believe, is 89. 89 all over 33. Of course, when you see the number 89, if you're from Illinois, you know that stands for 89 WLS out of Chicago. 33 goes into 89 2 times, almost 3, 2 times, that'd be 66. So that'd be 23 left over all over 33. It did not reduce, so it gets a mixed number there, 2 and 23 33rds. All right, almost done here. One more with just regular numbers before we handle the fractions with the decimals, or with the variables in them. I'm going to change this, just like I did up here in sample B, I'm going to change this one to adding the opposite. This becomes 35/8 plus 5/3. Well, again, these are mutually prime, so the product is the LCD. It's 24. So this will have a denominator of 24, and this one will have a denominator of 24. 8 times 3 gives me 24, so 35 times 3 is 105. 3 times 8 is 24, so 8 times the top gives me 40. So everything's positive. I add up the numerators. That's 145, and then keep it all over 24. Now I'm looking to see if anything will divide top and bottom. And I don't think it will. 3 doesn't divide into 145 evenly. So I have to do some division here. 24 into 145. I believe it goes in 6 times. It does. It goes in 6 times with 1 left over. So this is 6 and 1/24 for my answer there. Now the next 2 examples have variables either in the numerator or the denominator. It's easier with the numerator because you want to have your denominators workable and nice neat numbers like that. I can see my LCD is 15. So I'm going to go ahead and work this one out just like I did the other problems by getting a common denominator of 15. So 5 times 3 gives me 15, so 3 times the top. Well, m times 3 is 3m. And times 5 to get 15, so times 5 here. 2m times 5 is 10m. This is a non-traditional subtraction. I have to subtract the numerators, and they are like terms, so I can subtract them, but I'll change it to adding the opposite. A positive 3m and a negative 10m is a negative 7m, and that's all over 15, which does not reduce. That's my answer. Now the last one is probably as messy as they're going to get because my denominators are variables, and they're different variables. So since they have nothing in common, the least common denominator will be the product of the 2. So it's going to be Vx, Vx. So what times V gives me Vx? Well, I'd have to multiply it by x. So I've got to multiply the top by x. That's 3x. And what times x gives me Vx? Well, I'd have to multiply it by V. So I have to multiply the top by V. That would be 7V. So now my common denominator is Vx, but my numerators that I have to add are not like terms. So not much I can do here. I'll just leave it as 3x plus 7V. And that's all over Vx. And that's about as strange of answers we've had so far. Now, it takes a while to get good at this. You've already had some practice in the past We're mixing in some variables to make it a little bit more algebraic rather than just arithmetic. But like always, you must practice, practice, practice.